Billions of years ago, Mars might have had flowing rivers, shimmering lakes, and a sky tinged red with dawn. Now it lies cold and silent. But what if hidden in that silence are tiny chemical messages from a time when life could have taken hold? On March 24, 2025, scientists announced a discovery that brings us closer to that possibility. NASA's Curiosity rover has identified the largest organic molecules ever found on Mars. These chains of carbon could be relics of ancient chemistry and maybe even signs of past life. Let's walk through what was found, why it matters, and how it might reshape our search for life beyond Earth. The big discovery. Think of this. A rover drills into an old Martian rock, reopens its data with sharper tools, and finds something extraordinary. That's exactly what happened. In May 2013, NASA's Curiosity rover drilled into a rock called Cumberland in an area named Yellowknife Bay inside Gale Crater. This spot is believed to be an ancient lake bed where water once flowed. The powdered rock sample was studied and stored years ago. Then in 2025, scientists took another look, this time using improved data analysis methods. What they found was astonishing. Long carbon chains, far more complex than any organic molecules ever detected on Mars before. These include decane, 10 carbons, undecane, 11 carbons, and dodecane, 12 carbons, straight-chain hydrocarbons that are among the simplest yet most vital types of organic compounds. Earlier Mars missions had found much smaller organics, but never ones this large. Curiosity's SAM, Sample Analysis at Mars instrument, heated the rock powder, releasing gases that were separated and examined. Though the amounts were minuscule, just a few picomoles, they survived despite Mars's brutal radiation and oxidizing surface. The thrilling part, these carbon chains may be fragments of fatty acids, the same kind of molecules that form cell membranes on Earth. This means that ancient Mars may not only have had the chemistry for life, it might once have hosted it. Why this discovery changes the game. This new discovery on Mars is not just another "we found organic" story. It changes how scientists think about the red planet. First, it proves that preservation is possible. Despite harsh UV light, cosmic rays, and chemicals that destroy organics, 10-12 carbon chains survived, meaning something protected them, maybe clay, ice, or buried rock. Second, these larger organic molecules were found in a 3.5 billion-year-old lake bed, a place rich in minerals where life could once thrive. This shows Mars once had friendly, not hostile conditions. Third, long organic chains are more meaningful than short ones, as they suggest lifelike chemistry, not just random reactions. Altogether, Mars now seems less like a dead world and more like a planet that might have sheltered clues to past life. What are organics anyway? To understand why this discovery matters, let's review a few basics. Organic molecules are compounds mostly made of carbon and hydrogen, sometimes with oxygen, nitrogen, or sulfur. They form the basis of life. DNA, proteins, fats, and sugars are all organic. On Earth, fatty acids are important organic molecules that help build cell membranes. Finding them doesn't prove life, but they show how life can organize itself. The molecules found on Mars, decane, undecane, and dodecane, are alkanes, simple hydrocarbons found in petroleum or formed naturally through chemical reactions with gases. The key is where they were found, in an ancient lake bed. Curiosity and its tools. Curiosity, NASA's Mars rover, has been exploring Gale Crater since 2012 to find out if Mars once had conditions suitable for life. Its main tool for this detective work is SAM, or Sample Analysis at Mars. SAM includes ovens, chemical reactors, and instruments that can separate and identify gases. First, Curiosity drills into rocks and collects powder samples. These are heated to very high temperatures to release trapped gases. The gases then pass through analyzers that detect different molecules. This process can even find fragile organic compounds by adding chemical tags to protect them. However, Mars is a tough place for organics. Perchlorate salts can burn them when heated, and radiation destroys them over time. That's why finding long carbon chains is a big success. Scientists also use better software to uncover faint signals from older data. Curiosity keeps climbing Mount Sharp, continuing its search for ancient, organic-rich rocks. How this changes our picture of Mars and life. This discovery doesn't prove that life ever existed on Mars, but it makes the mystery far more exciting. For the first time, scientists found complex organic molecules, long carbon chains, hidden in ancient lakebed rocks. This means Mars was once more welcoming to life than we believed. These preserved molecules suggest that parts of the planet were wet, stable, and shielded from radiation, creating perfect conditions for chemistry that could lead to life. The find also changes how future missions will search for biosignatures. Instead of focusing only on simple compounds, scientists will now target long-chain hydrocarbons and fatty acids. They'll also drill deeper to find more protected layers. Some experts still argue these organics could form through natural, non-living processes, but the evidence keeps getting stronger. Mars may not be alive today, but once it might have been. The backstory. For decades, Mars has been playing a cosmic game of hide-and-seek with life's building blocks. In 1976, NASA's Viking landers searched for signs of organics but found only puzzling results, possible signals that later seemed chemical, not biological. In 2008, the Phoenix mission discovered perchlorates in Martian soil, chemicals that destroy organics when heated, complicating the search. Then came Curiosity in 2012, which uncovered tiny chlorinated and aromatic molecules, teasing the possibility that organics could survive, barely. By 2021, Perseverance landed in Jezero crater, collecting samples rich with promise, while China's Zhurong rover detected alkanes, confirming Mars hosts organic chemistry at multiple sites. The upcoming ExoMars rover, set for 2028, will drill deeper, beyond radiation damage, into zones where ancient molecules may still hide. And soon, the Mars sample return mission could finally bring these treasures home. The 2025 discovery now marks a thrilling new chapter, hinting that Mars's story of organics spans both time and terrain. From Mars to Earth? The next big step in Mars exploration is bringing samples back to Earth. The Mars Sample Return (MSR) mission, planned for the 2030s, aims to do just that. Perseverance rover has already collected rock and soil samples from Jezero crater, which will later be retrieved, launched off Mars, and transferred to a spacecraft bound for Earth. Once here, scientists will use advanced instruments to look for tiny traces of amino acids, lipids, and other potential signs of life. This mission is extremely complex and costly, requiring careful handling to avoid contamination. But the reward is huge. It could finally confirm whether life ever existed on Mars. Such a discovery would forever change science, philosophy, and humanity's understanding of its place in the universe. In conclusion, Curiosity's unexpected gift from Cumberland is more than just a data update. It's a revolution in how we view Mars. It shows that long, complex organic molecules can survive over billions of years in the right settings, even under harsh Martian conditions. As we push forward, drilling deeper, bringing samples home, comparing craters, testing new hypotheses, we're not just chasing molecules. We're asking whether life is rare or whether the universe is more generous than we've assumed. Next time you gaze at the red dot in the sky, think, within those rusty plains and silent craters, there could be whispers of a long-lost world. And with every new discovery, we listen more closely. Like what you saw? Subscribe, share your thoughts below, and stay tuned for more content. Thanks!